Alright, so we are coming back to yesterday's repair and going to look at the trace lines that were completed. I've actually already tested this unit and gone through it. It does hook up to the TV and now is functional. Have not gone through the final steps of checking all the other parts and components that need to be corrected on it. However, it does boot. The HDMI repair was successful. Our trace lines, as you can see, we have two that we had to fix. One which is visible from the top and another one that is underneath. This one, very easy to see, the connection goes straight from the line to this position here, and continuity can be easily tested by using your multimeter in continuity mode. As you see, when we tap these contacts, we're going to get, let me check our lighting here. Okay, we are all the way up. For some reason it's really dark in that background camera. I may have to take a look at what settings that has, but we're still visible. Alright, so in continuity mode, when we tap the contacts, we get a beep. This is where it gets a little tricky. Go ahead and put one probe just in terms of positioning, because we want to make sure we only make contact. And again, the up and down to these is they're removable, but they get loose. In fact, I'm going to take these tweezers. There we go. So we have continuity between that joint, not with this. Now the one that was hard to identify yesterday, and it got where the video ran long, so I'm just coming back to it today because I was ready to call it a night and didn't want to look up what pin number 19 goes to. And let's see, how did I do this earlier? We did, so we have pin 19 goes here. And if you had watched yesterday's video, and you can always go back and see it on the YouTube channel, but there was a wire installed underneath that ran through a via. And although that via does travel all the way through to the bottom of the board, it is running out and comes over here. And it may intersect at some other points. I haven't gone through to probe everything in the area to verify that it doesn't, but we know that it goes to this diode. And if we just tap the tip of that, we find that we have continuity. Now I did go back with my soldering iron. I'm a little stuffy at the moment. And I cleaned up this pin next to it because there was a little bit of what I'd call like oversplash of that solder where it just kind of fingered out. And it wasn't making contact, but we wanted to make sure that it wasn't ever going to before we seal this area up, which is what we're going to do now, because like I said, I've verified all of these pins are good. We can pull it up, we get the PS logo, and then without the hard drive connected, it goes to can't detect hard drive. So what we're going to do now is bring back out that solder mask, the same one that we used yesterday, and we're going to put a little just for the benefit so that everyone can see it. I'm going to dab it in this area, which I wouldn't normally do, and that's a lot less than what I used yesterday, but will probably still be more than enough for our purpose. And if it's not, we can always add more. And so basically what we're just going to do is cake it, and then we will thin it out because we don't want to have it where it's that thick. Otherwise, even with this new stronger LED, UV LED, it would have a bit of a problem curing big puddles. And we don't want to make it to where it's still liquid under there. We want to have it to where it's fully cured. Now, it's really not important to have all of these done. What we want to make sure is that we have the ones surrounding our jumper wire. And we want it to flow into those grooves, and this will just kind of help also stabilize that leg, because remember, that pin is free floating. It's got nothing bonding it to the board. So we want to try to just anchor it to its position so that it doesn't move. And obviously, once it's sealed up, this part is not going to move, but when a person's putting their HDMI in and out, and things are going to shift a little bit. And what we want to make sure is that they can't shift in a way that they'll cause a short. And I'm not wearing gloves at the moment, but we're also not working with anything other than UV cure mask and just probing points. Being gentle, just not to rip any of this, because then we defeat the purpose of all the work we did yesterday. Alright, slow and steady. Now we're going to clean up this spot. Because that is not needed for what we're doing. Go ahead and give it a tilt. We're going to zoom in here real quick. We want to make sure that our mask is penetrating down into those legs. As we can see, it started to, but it hasn't really made that transition yet. I'm just going to prop this board up, because if I put my hand back there, it's going to kind of get in the way of what we're doing. But we need this board on an angle so that we can look down into what's going on. Alright, so we want to force feed a little more. Now try not to get it over the top of the joint, but it's okay if it does. To kind of force this down in there, it's probably going to require it. Alright, we're starting to get a bit of a puddle, and that's where I do want the puddle, and that's where the stronger UV light from the LED really becomes a benefit, because it can cure small puddles. That old one that I had could not. Well, I shouldn't say that it couldn't, but if it was one like this where I really wanted to stabilize this leg, and it's got a bit of a deep well here, then I'd have to usually let it sit overnight in the old one. And for those that do have those old school UV cures, they're very commonplace in the screen repair. You have a toggle switch on it that gives you either like a timed, and I think it does 2 or 3 minutes, or there's an infinity symbol where you just flick it that direction and it goes into an always on mode. And I would just turn that on and let it sit overnight if it was absolutely important to have this step completed. But this is going to be a great opportunity to show how fast this one can cure, even with a fairly thick buildup here. And as you can see, we forced it into the area where the joints were, or where our trace builds were, because those are the ones that need it. But these other ones we're not worrying about, because they're mounted to the board. They don't need that extra support. Also notice that the exposed area where this enamel wire is gold and then it gets to the solder, that kind of high polished look, we want to cover that. We want to make sure that, you know, something does fall on it that happens to be conductive, it's not. Or if for some reason this pin does move, that it at least eliminates the chance that it could bridge a joint, electrically bridge a joint. Alright, so now you just need to reapply power to this big old chunk of a fan. And there are probably better thermal casings for this LED, something that would also give me a little bit more flexibility. But this is what we would call a prototype. It works for now. It keeps it from overheating. And also, while we're on the subject of these LEDs, in yesterday's video, we went to use the LED and it didn't work. Well, eventually we got the one that was working before to go back to fully functional. Not sure if it was reflowing it using the hot air that fixed that issue, or if it was the fact of pulsing the 3 volts through each individual cell somehow kind of reactivated it. But bottom line is we got it back up and running. Now on the other one, because I did buy 2 of these, which are slightly different, it never worked, and it still does not work. Well, I should say I finally got it to where 3 of the 4 LEDs in its array are now functioning. And that is because one of them, once I went into an extreme zoom on the microscope, you can tell where it has, I guess, either a crack in that LED's top surface, or if it is blown on one of the LEDs, but it's actually the one that's closest to the negative connection. And so 1 out of 2 from this company was defective. What I'll probably end up doing is asking for them to refund that one, or if they want to send a swap for it, that would be acceptable too, but I don't think I'll buy from this company again. Alright, it looks like this LED, it doesn't even kick in until we hit 12 volts. And then starts to pull amperage at 13. And then kind of gets to its sweet spot around 13 and a half. I think it does say when they're listing that the max is 14 volts. And this is where this gets a little awkward, is trying to make sure nothing shorts while, there we go. And you can see that light now underneath. But like I said, this light makes doing this in a live stream possible, because if I use the other system, I would have to let this cure overnight. And nobody's going to watch a live stream for that long. And in a few seconds, we'll lift it up, give it a check, see where exactly it's at. And it'll probably need a little bit more before it's finished. Take a look at that. In a very short amount of time, that's already started to cure. Now what I want to show is we should still have bubble in here. We should have almost kind of like a gelatinous phase. I need to clean this off because it's still wet. Well, it does have a little bit of give, but it's barely any, and that's the difference of this LED. It wasn't down there for long, but it's already stiffened quite a bit. So maybe one day I'll do a comparison video. Oh, look at that. My LED actually popped off of the heatsink, so I just put it back on. I'm currently just using thermal paste to mount it. I need to actually use a thermal epoxy. And that'll prevent it from being able to separate because it'll actually be glued versus traditional CPU thermal paste is non-hardening. So all it takes is a little pressure and it'll basically pull itself off. Now remember, if you are working with UV light, you don't want to stare directly into the light. It will damage your eyes. Which is also a benefit of the heatsink. It prevents you from being able to look directly at it. And I'm going to take a look up underneath just to see where we're at. This is the boring part. Like I said, normally I would just kind of set this up and let it run and move on to something else. But I wanted to show it in the video, and we are using a prototype here, so it's a bit janky, so I have to sit here and hold it while we wait. Let's go ahead and take another look and see what our progress is now. Alright, so this part is hard. This is cured. And there is also a heat-cured mask so that you could bake this. But that is it. And like I said, if I would have done that on the other one, this would have been buoyant. When I pressed on it, it would have kind of squished like a marshmallow or a pillow and then kind of pop back, and you would see the indent impression of where it had been pushed. And with this, you don't get that. I mean, obviously I can make a dent in it, I can scrape it away, but it's solid for the most part all the way through. And if there's just a little bit of it that is not completely cured, once that reaction is started, it should finish up as long as there's not an enormous amount of uncured product over there. But that took care of it. And just to show, get the full, all of it in there. And now let's back it up so we get our full effect of the light. And when you do this, I mean, I could make it look prettier, but like I said, I could have taken a bit of cellophane and used it to press. And that would have flattened that out and give us more of a finish like this. But pretty was not the goal. The goal was to secure everything, and also to make that stronger. Having a bit of that buildup helps to better encase it, if that's a good way to say it. Alright, so now, just to finalize this, alright, so to review, we rebuilt two traces, one here at the end, pin 19, and also this one, I forget which number this is, and I'm not going to count them. We then sealed it with a UV mask, and we have continuity between pin 19 and this diode. This one, as you can see, runs straight through, and that completes that part of the HDMI repair. Now, before this goes back into the machine, like I said, I've already pre-tested it so that I know that the HDMI works. The only thing we need to do now is wrap it up. And as you'll see, I've reinstalled new thermal pads on the RAM, as well as we're going to put down a fresh layer of thermal paste. And what I'm checking now is to look and make sure that we don't have any debris, bridges, random stray whatevers on these components. And they all look clean and good. You can see that old solder paste still kind of on the edges. If you wanted to clean that up just to remove it, this is where the go-to Q-tip. It's almost like it was made perfectly for that section. And now, we are going to take, where is that? I think that, oops. So looking for the thermal paste tube. You know, and I actually finally got a hold of Arctic to buy thermal paste from them directly. I'm still waiting on an email. It's only been like 2-3 3 weeks, and getting somebody on the phone because prior emails were unanswered was almost a year before I lucked up and got someone. So I actually bought the Arctic MX4, which has a very good thermal transfer rating. And can be bought from a known and trusted source. Buying Arctic, and this is something, the Arctic Silver thermal paste, unless they get better at working with small companies directly, they're a pain in the butt. And all of their distributors, even the ones that are direct, like Amazon is supposed to have a direct relationship with them. I think Newegg has a direct relationship. But the problem is these sellers also allow third-party agents, and they don't make it clear which product is theirs versus which product is someone else's. I think Amazon has gotten better about this because I've noticed the last couple of things that I've bought from them has a different designation when it comes from them direct. So maybe I could go back through and look and find one and know with confidence that it came from the manufacturer, but I haven't found one yet. So if they are listed as a seller, maybe they haven't rebought in a while and Arctic Silver just never took it down. Maybe that's the case, but I don't want to buy it from Joe Blow that is potentially buying some knockoff brand from China and it's being passed as original. It's just something I wouldn't want to trust to a random, because if it doesn't perform well, it's going to overheat. And I'm looking at this, just trying to determine if that P size is enough. And I think it'll give us, yeah, that's going to spread. That'll be fine. It doesn't take a lot, and this is where a lot of people go wrong. They'll use way too much. If you use too much, it'll insulate rather than conduct. So you got to get the right amount. There is a way to be extremely precise, and I was building my own, but I think I'm just going to go ahead and buy one of the units for like $100, and that is it's like a pressure timing controlled. It's technically a semi-automatic solder extruder for using liquid solder, but you can also use thermal paste, and you can basically set and tune your settings so that you get the exact same amount every time based on the die profile of the CPU. And there you go. I don't know if that was always in view or maybe possibly not. It might have been sitting behind that top little picture there, but that's as big as it is. And if we turn it sideways, you can see it's a little out of focus, but that's not a big gob. Alright, and before we mount this back into the frame, we're actually, I don't know if this will really stay in focus for this part or if we'll be able to get it. It's a large area, but through the back camera you can actually get a pretty good idea of what's going on here. We're just going to take off these 3 screws from the case. We're going to open this up. As I said before in yesterday's video, this was an infestation machine. I'm actually, rather than going through and fully cleaning the infested, I am just swapping it out for one that we had on standby. And I want you to take a look at this, because this came, which one, you can see it here, this is the bottom. This came from a customer's machine that was unfixable, and they donated the parts. So it's just been sitting on standby for the day when we need it. But there is a ton of dust, and this is what basically killed the machine. You can see it on that back camera on that fan really well there. The APU just overheated. And that's because there was literally no airflow. I mean, look at that. That is a cake. And I get machines like this all the time. And this is not a once-off. Not always does it result in death, but every now and then, blowing duster or whatever you're pumping through it will not fix the issue, especially once it's caked up like this. Remember that this stuff is static charged. Dust is going to cling, even if there's just a little thin film there. And so this is actually worse than I thought it was when I grabbed it. I could grab another one, or I think what I'm going to do is I'm going to step away for just a second. I've got a cleaning station set up to where I can brush this off and blow air through it. But just to show the kind of brush that we would use at that station would be like this. And we're going to blow air as well to make sure that we just knock off all of that dust so that we kind of help to dissipate its buildup and prevent it from being able to quickly use static to bond new dust to it, making that layer build up faster than it would have. Alright, so live stream video, maybe I need to put up a quick pause, but it'll take literally 60 seconds. I'm not going to kill the stream for this, and I'll be right back. Alright, so like I said, didn't take long at all. Still have a few quick cleanups to make. And that is just by taking again a Chem White. And getting off some of those last little remnants of dust. One of the things I've thought about for this was just getting one of those really large, cheap tanks on the ultrasonic cleaners. Drying would take longer, but it would take equally about as much time to just dip it, let the ultrasonic hit it, and then knock it off. And you don't need a high quality precision ultrasonic for just hardware cleanup. Now if you wanted to put a board in it, that's where you probably want to spend some money, especially if you want to fit the size boards that come on gaming consoles, although they are making them smaller and smaller. Using that combination of air and the brush to get this really clean. I don't know if you can, trying to get an angle that will show that now, but this was caked with that little basket of dust. Or not really a basket, but a basket full maybe is what I was thinking. Alright, so that's been cleaned. There is one last thing to clean before you want to reassemble when they're this dirty. And that is where we want to take out the fan. I'm trying to get this to where we've got our camera. Okay, so there we go. And so now, let's see if we can get an angle that shows it on that back camera. Yeah, you can see that. All that dust up under there. And if you look at the fan, you got plenty of dust on the blades. And you just, even the air and the brush, just can't get it when it's tucked down inside of that. But once we take it out, we can hit it. And I normally would not do this on the bench, but just to show. Probably saw a little poof of cloud or dust pop up there. Okay. Now, one thing that it makes me angry with manufacturers, they want nothing to be serviceable. They want nothing to be fixable. They want you to have to buy a new everything when the simplest of things breaks. If this fan was to have broken, which they rarely do, and I will credit Sony on that, the fan is decent quality. But they make them non-serviceable, and I'm sure they have a way to service them, but this is sealed. There's no way to open this up and simply just grease and lube or rebuild your gear for that fan. And it's not that it's cost effective to do, but if you were servicing it yourself, hey, why not? Why go out and replace it if you wouldn't need to? Because how many of these fans end up in a dumpster somewhere simply because the manufacturer said, if the fan breaks, I want you to have to buy a new PlayStation. Like I said, we're not going to get this perfect, but we are going to get it far better than it was. There will probably be some speck of dust on here, and this is what a ultrasonic cleaner would handle quite well. You'd be able to dip it, and it would just blast that off. The problem with this, though, is it's not really recommended to do that because it's not serviceable, so we're going to get moisture inside where the bearings are, and there is grease, which will hold and suspend that water, and that's just not going to work out well for it. So a routine maintenance procedure couldn't be accomplished because they sealed the unit. And I get it. You know, you gotta make money somehow, but I don't think that making it where fans are not third-party serviceable is going to make the difference in their bottom line. I mean, obviously, it does result in some additional sales of PlayStations, because out of all the people that bring it and do actually have a fan problem, which is not that many, where they say, oh, it's just the fan. Very rarely is that the case. But it does happen where simply replacing the fan fixes the overheat issue. Because for whatever reason, maybe that was a defective fan, maybe just the way the wind blew that day, it decided to get wonky. Like I said, again, it's a rarity that nothing more than a fan would be causing the overheat issues. I have also seen it where replacing just the fan has worked. It has resolved the issue. But because that fan was bad for a while and had to get to an extreme before the customer decided to bring it in to service, or before they realized something was actually wrong, the damage to the APU had already been done, and it wasn't irreversible at that point. That was nothing more than, at least I never got the machine back, it was just simply that it needed to be reflowed after the fact. It started failing again for thermal reasons, and the fan was replaced, so we knew that was no longer an issue. Did a reflow, and it's been over a year, and that machine hasn't been back. So the assumption is that the fan failure allowed the machine to get hot enough so that those solder joints became oxidized and brittle and ended up cracking, creating bad contact, which then resulted in overwork on the APU, which then caused an overheat. And once that thermistor detects too much heat coming off the system, it goes into a safety shutdown. If you're not familiar with what a thermistor is, look it up on Google. There's not much in the world you can't find out with a quick Google search. I think now I'm just having fun. I don't know. There's something methodic about removing dust. I don't know. Maybe that's me. Maybe I'm weird. Like I said, this is not normally how I like to do it, but I guess sometimes you make compromises for the sake of doing these streams, and it's certainly not the fastest way to go about this. I would have already been done a long time ago if I wasn't trying to do this in a method that I could record it. Alright, so now we're going to hit this one more time with the brush. Alright, and now that that is done, we can put the fan back in. And if you wonder which way the fan goes, let's see again if we can get this in view. It's actually, it'd be hard to remember if there wasn't an easy clue. That easy clue is your wire. It has to connect to the board at a certain point, and the board can only lay one way, which means the fan can only go one way. One of the things that does always get a little bit tricky, though, and if I remember correctly, before I go and put this up, it will be this screw and this screw go in, but this one does not, at least not yet. And the reason being is that that screw goes over this shield. So now that we've confirmed that, I'm going to go ahead and put these two screws back in. Sneaky screw. And as I said before yesterday, I will only ever live stream, so you'll get the bloopers. You'll get the, oh, I forgot to do that earlier because I probably should have cleaned this before we got started, but I forgot. And as I said, I'm not going to edit videos. It just takes way too much time. So I'm live streaming whatever I do. As long as it takes any mistakes, they're all going to shine. The benefit is you'll also get the raw and gritty. So rather than seeing what appears to be a perfect repair, you can see the mistakes that are commonplace, things that happen in real-world environments, obstacles that people that have done this several hundred times over still will make. I think even a Fortune 500 company doing this with highly detailed and specified operations would have your standard kind of hiccups like that. In fact, I watched a really neat video the other day of this company that makes like custom high-end computers. Like they would build you something for $20,000, and they were doing thermal profile testing after the build and construction to determine where to place fans and other stuff. I wish I remembered the name of that channel. When I do remember it, I'll have to put a little link to it, just so if you want to watch, you can. Just like I said, I found it interesting to see a company that took building computers, an art that really most think is dying, that people just go and buy off the rack, and they do, except if you're looking for servers, or now with everybody that is streaming, you'll find people demanding more power than what any large-scale manufacturer is going to pump off the shelf or into a Best Buy or a place like that, and it's creating an opportunity. Okay, so we've put this back on. We've already applied our thermal paste, which is what we were waiting for. And now we're just simply going to slide the board back into its location. We want to make sure our thermal pads do not come off, which one of them did. So we're going to place that back. In fact, what we will actually do is, it should be there. Alright, so when I insert this, and again I'm doing this with all of my cameras over the top of it, so I got to do it a little weird by, I'm going to stick my head up under the side here and look and make sure no more of those pads have drifted off. So we want those pads there. We need them there to help transfer, just like the paste that we put on top of the APU. Those pads are going to help move and direct heat off of these guys. These are the RAM chips. And on this particular board, we have them on both sides. On later generation boards, there's only on one side because they were able to get the same chip with double the capacity of RAM in it. And so there we go. Now that it's mounted on, there is also a top plate that would go over this. Then we have the anchor brackets, which help to basically apply. Let's see if we can get this in view. As you can see here, we would have the anchor brackets, and those would then mount and put pressure down over that APU so that paste is making contact all the way around the die structure. And that's what allows the heat to transfer. And then that fan that you saw that we removed is going to take the airflow from the side here and blow it and force it through those fins where we had the buildup of dust. And that's why that buildup is, you don't want it. It's because now that air couldn't move through those fins and push that heat off of them. Think like the radiator in a car. It's using water to move through those fins and remove heat. In this area, we're simply just using air, and that air pushes past those coils that are radiating the heat and then moves it straight out the back of the machine. If it's blocked, if it's obstructed, if it can't move at the airflow rate that it was designed by the manufacturers, you're going to start having performance issues. Okay, so for this repair, we're going to end it there. We showed where the HDMI was connected. I am having an issue with, I got this, what is this thing called? I forget the name of this company, but it was probably one of the highest rated ones on Amazon, and it's just a little 5-port HDMI switcher. But it looks like it's going to be difficult to find a quality switcher, and you need a good quality transfer to be able to get your PS4 signal to go from source, which is the console, to the it would run in through the switch. It goes then to the output, which goes to the encoder card, and then from the encoder card's output, it then goes back to the monitor. And what I cannot get is that signal to show up on the monitor. So I don't know if it's even showing up on the encoder. I know at one stage it wasn't. I changed out some cables to some higher quality ones, and that fixed the issue. But it looks like some of the signal degradation is still coming from the HDMI switch. And as we all know, if you're a PS4 user and you hook it up to a 720p and then you try to transfer over to a 1080, it is super finicky about how it establishes its handshake for, what's a good way to put this, quality designation. But this is, there's DDC and then there's something else, and we get into HDMI protocols, but it is really picky about how it authenticates on that HDMI. And if the switcher is causing some interference, it's not going to pass through properly. And I need that fixed because part of the setup was to get this to show through and then even be able to use repair verification where I stream the connection of a customer's machine so that they can see it be that it's verified as the HDMI output is repaired after it's been done, before they ever even come to pick it up. So that was the goal, but it looks like I'm going to have to look through some hardware options. A matrix switch is on my list, but again, the reviews on those are sketchy. If anyone knows of a good switch that works well with streaming, I could probably do a Google search and find some other people's recommendations, but when I was searching for one to get, didn't see any that stood out as the obvious choice, and hoping that to have a headache-free solution doesn't mean buying one that's several $100s, because they do get hundreds into the thousands, like Black Magic boxes, HDMI matrix, which is a little bit more smart than just a switch. I mean, those can cost you thousands of dollars. Alright, well, again, ending this video here, we've successfully repaired the HDMI. We know that we have video output when we go direct to TV, and the only thing left now is to go through the final swap outs, where we're going to do a swap on a hard drive. We got to throw the Blu-ray in and make sure that there's no issues with that, but other than that, this customer should be back up and running before the weekend. Again, this is Circuit Repair Augusta. Also, you can find us at PlayStationRepairAugusta.com. If you have a repair need, whether it be electronic in general or a gaming console, send it to us. We'll give you a free diagnostic, and if you're ready to get it fixed, we'll take care of that issue for you.